Alright folks, we've got a doozy of a problem now. We're talking about projectile motion problems, so this is in 2 dimensions, but now our velocity is going to be at an angle. So here's the issue of a cannon firing a shell at a degree angle at a speed of 100 meters. If the cannon is top of a 40-meter cliff, how far from the base of the cliff will the shell land? So as is always the drawing a picture will be a fantastic help. We have a cannon firing at a 40-degree angle, and so this cannonball will travel a path that looks something like that. This is projectile. The speed at which the cannonball left was 100 meters per second, and we also have a 40-degree angle, and we can assume that that is from the horizontal, like that. In fact, let me zoom in a little bit to give you a better image of that. Other information that we know that the cliff is 40 meters, and we also know the acceleration due to gravity will be 9.8 meters per second squared, and that will be downward. And other than that, we are not given any information past that. So what we need to do now is determine a couple things. First, we have to know everything we can find about this velocity. So we're going to have to break this vector down into components. And then from there, we're going to have to list everything we have in the x and the y direction and figure out what we need in order to solve the problem. Now, one thing that I want to take care of before we do anything else is to decide what's going to be positive and negative directions. And I'm going to go ahead and say, as is my usual, that in the y direction, positive will be upward, negative will be downward, and in the x direction, positive will be to the right, negative to the left. And so that will now give me a frame of reference for anything I'm doing later on. Alright, so first things first, we need to break up the velocity vector into its components. So I'll just redraw this. We know the hypotenuse is 100. And I'm going to draw my right angles here. This angle is a 40-degree angle. And I need to find the x component of the velocity and the y component of the velocity. And the way this works is if I'm wanting to find the x component, that is the adjacent side to that angle. And if you remember SOHCAHTOA, cosine is the one that deals with the adjacent angle. So I can say that the cosine of 40 is going to be equal to the adjacent side over the hypotenuse. And so my x component will just be 100 times the cosine of 40. And huzzah for calculators. We end up with 76.6 meters per second in the x direction. Now, for the y direction, the y component of this vector, the y component is opposite of the angle. Again, SOHCAHTOA, we can hear that the sine has the opposite part. We could also use the tangent function if you really want to, because we do now have the x component. However, since this is calculated and rounded, we get more accuracy from using the sine function. So the sine of 40 will equal the y component over 100. So the y component will be 100 times the sine of 40. And again, hooray for calculators. So punching this in, I find that my calculator is very slow. Aha. 64.28. So now I have my speed in the x direction, 76.6 meters per second, and my speed in the y direction is 64.28 meters per second. Now notice that all of this, and we still really haven't even started solving the problem. This is all just set up for this one very massive problem. Now that I have all this, though, I can start setting up everything I'm given. And so I'm going to switch to a new sheet of paper just so that we have room here. And I'm going to list everything we are given. And I'm going to do this for the x and the y directions. So in the x direction, I do know the initial speed, and I know this from my calculations here, that the initial speed in the x direction was 76.6 meters per second. I can say for my initial position in the x direction, not that it matters much, but I can call it 0, so I can say that this is 0 on the x-axis. If I really need to, that's not an issue. I can also say something about the acceleration in the x direction, because if we look at this, once the ball has left the barrel of the cannon, there are no more forces in the x direction, so my acceleration is going to be 0 meters per second squared, and that's about all the information I have there. Now, for the y components, I know the y component of the speed is 64.28 meters per second. I know my initial position in the y direction, and here's where I have to start being careful. I need to put someplace as 0 on this, and I can pick any place I'd like to be 0 in the y direction. I can select where the ball starts from. I can select that as being 0. However, if I select this as being 0 meters, notice that now all these displacements become of the same sign, and I'm not going to be changing sign as much. But either way you want to work it, you can make this 0 meters or this 0 meters, and that changes the initial position of your cannon in the y direction. So in this case, I'm going to say that that is 40 meters. I'm making 0 right down here. And so my cannonball starts at a height of 40 meters. Notice I'm kind of ignoring the height of the cannon. It happens. All right, what else do we know? We know the acceleration is going to be negative 9.8 meters per second squared because we're accelerating downward. And that's about all I know at this point. If I want to, depending on where I select the final position to be, I can talk about a displacement, but we'll jump more into that later. All right, what I want now. Think back, way back when we started with a problem like a couple hours ago, it seems like. How far from the base of the cliff will the shell land? So we want to know this displacement right here. Notice that that's in the x direction. So what I want is the displacement in the x direction. Now notice there's a problem here. Acceleration is 0, so I can use the equation v equals d over t to solve this, except I don't know d or t. I need to find the time first. So what I can do is I can hop over to my y area, and let's find the t, the time, using that. Now I'm wanting the time when the ball hits the ground, because that's what I want to know, is how far away it is when it hits the ground. So I can also say something about my displacement in this case. My total displacement is going to be 40 meters downward. So that is negative 40 meters. And using this, I now have everything I need to set up an equation to find the time. Namely, I can use the equation displacement equals initial velocity times time plus 1/2 acceleration times time squared. And all I have to do is plug in what I know. -40 equals 64.28 t, I don't know what time is. 1/2 times -9.8 would be -4.9 t squared. And now, notice that I'm left with having to solve a quadratic. Now there are a couple ways to do this. You can graph the quadratic, or you can use the quadratic equation. Whatever works for you. I would recommend the quadratic equation just for ease of use. And for the sake of time on this video, I actually have on the internet pulled up a calculator that will let me just type in the numbers and it will give me the solutions to the quadratic. I have no problem with you doing this for practice, but I cannot let you do it on the test. So it's your choice how you want to do that. And when I enter in this into the quadratic formula to solve, I find two solutions. Time equals -0.595 or time equals 13.714. Now, stop for a second. This is a value of time. How many seconds have passed? One of those solutions makes sense, the other does not. Remember, when you have a quadratic, you will find two solutions. We can't have a negative time. That does not make sense. Therefore, we can toss that as an extraneous solution. It is a solution. It works. It solves the math problem that we had at hand, but it's not the solution we're looking for. This is. So our time is going to be 13.714 seconds. And notice that time is the one variable that you can use in the x or the y direction. And now I have enough information that I can plug in velocity and time. So I can say that 76.6 is equal to the displacement over 13.714, and my displacement, how far this will travel, will simply be 76.6 times 13.714. And of course, I typed that in incorrectly into my calculator, and I'm forced to do it again. So that is a displacement of, ignoring sig figs, 1050.49 meters. And this is my final answer to, oh my goodness, this problem from long ago. The distance that shell will travel is 1050 meters.